I'm not sure.
I think we should.
It may not be tomorrow.
But will it be a take home?
Yes, I just, because we've kind of like gotten slowed down today, I'm not ready to give you a take home for tomorrow. Okay, that's all I'm saying. Okay. Can I ask, was everybody able to get this far in terms of the equation? 240x over x squared minus 100.
Yeah.
Did everybody get that far? If you did not.
Maybe. No.
No?
Not really.
Okay, back up a little bit.
I found the way that the question was worded confusing because it was like she's going 120 miles north on a round trip. I didn't know if that meant like 120 there or 120 back, or if it was 120 the whole
The thing is 120 miles north, and it's round trip, so it's 120 one way.
Okay.
Okay, so you're right, that can be confusing, but, and, let me see.
Wait, how did you end up with 240?
Hold on a second, I'll get there.
I don't know what I said. And then what about the hours?
So she's planning, Haley, it is that. She's planning to fly her plane on a round trip to an airfield 120 miles north. So you know she has to go 120 miles north and then she's going to fly back. All right? So in setting this up, all right, I'm just going to, I knew that my distance was 120 and I had the wind going in one direction and then I was going to be flying against the wind. Okay, is everybody all set with that? And then my common factor is, actually I redid the problem over here again. So I ended up multiplying this by x minus 10, let's see, and then this, the other side by x plus 10, and I ended up doing the distributive property, and I should have had 120x minus 1200 plus 120x plus 1200. The 1200s cancel out, and I have 120x plus 120x, which is 240x, and then it I multiplied this out. So I would have had x minus 10. Are these the factors for the difference of perfect squares?
Yes.
So I would have had it over what? X squared minus 100. Okay, and I know that it was an hour and 25 minutes. That's the information. Could you just hold on a second, Cassie? Okay, so everybody good with that so far?
Yeah.
Good? Okay, so, okay. I have to say, I did this problem twice because it didn't make sense the first time. The first time I did it, by the way, I converted those an hour and 25 minutes to 65 minutes. So I'm chugging along, and my answer did not make sense when I plugged it in. Because the question, which I reread, was asking for miles per hour. And is that in, did I do this in hours? So I had to remember to go back, and as I said, I went back and I calculated, 85 minutes is an hour and 25 out of 60, or I did the first time I did it wrong.
1.4?
It is 1 5/12 when I simplified it, which is 1.41666. Okay, so that's what I have for an hour, the time. Okay, so here is what I have. I have 240. I'm going to cover this up because I'm going to let you have the fun here. But everybody, I have 240x over x squared minus 10 equals 1.416. Does that make sense to you? Okay, so now what am I going to do? Do I want a fraction in the denominator?
No.
No.
Okay, so what could I multiply by?
X squared minus 100.
Yeah, on how many sides?
Oh.
Both sides. Okay, so if I multiply on both sides, what do I now have? 240x is equal to 1.416 times x squared minus 100. Yes?
Yeah.
So far so good? Okay. Can I multiply that out? All I did was 240x. I multiplied it out. I moved my 240 over. Okay, Kayla? And what do I end up with? This odd looking quadratic. This is where you're going to pull out your calculator.
Quadratic equation.
And you're going to use your new equation. So let's do that. We are going to go to,
Wait, you need to move the paper back up.
oh, sorry.
We need to see that.
Program.
We can see it.
You hit program, enter, and it'll go with quad 83.
Okay, everybody hear that? You're going to go to, let me see,
Program.
Wouldn't
two
it be
buttons
0.7,
underneath.
not 0.6?
Yeah.
program. And then since we only have one, or at least I do, only have one program there, I'm going to hit enter. Everybody should have program quad 83. I'm going to hit enter again. And now it's asking me for my what? A value. So I just need to plug in what? 1.416 or whatever, or 7. Okay, and hit enter. And look what happens. The B, they ask you for the B, which is, remember we're going to use that negative at the bottom, so it's a negative 240. I'm going to hit enter. I'm going to get C, which is a negative 141.6. What do you think I'm going to do next? Hit enter. And there you are. Is that pretty sweet? You like that, yes. I figured you would like that.
This is so much nicer than writing it out.
Well, it is, and and especially when you end up with.
Yes, it's elegant.
I mean, it is elegant, and does it make sense to use a quadratic here? Is this more accurate than graphing it?
Yes.
Okay. So
The most
it is, and I thought that you would enjoy having that in your little
Are there programs that do other kinds of graphs?
Yes, there are, but we're not going to discuss them quite yet. Okay.
Like that takes my final for me?
What? What did you say?
I said a program that will take my final for me?
Yeah. That is pretty cool. All right, so I apologize about number 11, and I'm sorry I'll have to do that again. All right,
That would be awesome.
what do I want to do?
Calculation.
We have 2 minutes.
I know. All right, so you know what? I have a few minutes left. Now, chapter 8, for the most part, we may have that chapter test yet, because chapter 8, for the most part, was all about factoring. And you learned how to divide. And I went back and I thought about, well, what did we learn? We learned some leading coefficients, right? The leading coefficient is what? The leading term. Okay? We learned about, we know that the constant, what is the value, the degree of this last term? 1. Could it also be, if this is a 4, this is a 3, this one is 1, could it be x to the 0?
Yeah.
Because x to the 0 is 1. Okay, so it is a 0, it's a variable to the 0 power. What do we call a degree? In the third term is a cubic, and a fourth term is a quartic. Okay. What happens if it's higher than that?
Whatever power.
It's just called by its highest, it's the 7th degree. Okay? Let me see. Does this have, is this a maximum or a minimum or a relative max, a relative minimum? It has a relative minimum because I can see that it's going to drop, and I have a relative max because I know it's going to increase. Okay, what would the degree of that graph be? It's a what?
Cubic.
Cubic. Yes, it is. It's a cubic. And it happens to have a bump in the middle of it, but it's a cubic. Okay. A quartic, when they're even, are going to face which direction? up, okay, if it's a portic, it's going up.
It's just really wide.
And, let me see, there's a box problem there that I was going to give you. All right, I am thinking that I will continue just reviewing this with you tomorrow. And I may give you the, take-home over the weekend, that would be a nice thing to do. And then I'm going to give you maybe 2 problems to do from there.
For tonight?
Yeah. Just to make sure that we're all set with that. So on 606,
Yeah.
11,
Hey, actually, we're supposed to move the comment section. Don't worry about it. No.
all right, hold on, sorry. 606. All right, so we did 5, 7, 9, 11, hello. No, not right now, I'll talk to you later. Let's do, how about 19 on page 607?
Wait, I need to look